They call it SPHEREx. It may be the key to unlocking some of the deepest secrets of the universe. While most of us are watching rockets launch or gasping at new images from JWST, this lesser known NASA mission is preparing for something more ambitious, scanning the entire sky, every direction in infrared light. It's not just another telescope. SPHEREx will map the cosmos in 96 infrared color bands, building a three-dimensional map of the entire universe. Every 6 months, a new all-sky survey. And each one adds another layer of insight into how the universe was born, how it evolved, and where it might be heading. But what exactly is it trying to find? The answer goes back to the beginning, not just the beginning of stars or galaxies, but the beginning of time itself. After the Big Bang, the universe expanded in a violent burst of energy known as cosmic inflation. This brief but profound moment left subtle fingerprints, tiny ripples in structure of spacetime, and SPHEREx is designed to detect them. It will also explore another mystery, dark energy, the strange, unseen force that's pushing galaxies apart and accelerating the expansion of the universe. SPHEREx may not explain what dark energy is, it will give us more data than ever before about how it behaves across space and time. And it doesn't stop there. SPHEREx will search our own galaxy for signatures of water, ice, and organic molecules, the raw materials of planets and, potentially, life. By studying the disks of dust and gas around newborn stars, it could help us understand how planetary systems form and whether our solar system is truly unique. This one spacecraft is looking at everything, the vast scales of the universe and the tiny chemical clues of habitability. It's a cosmic census, and now that it's launched, it might just rewrite what we thought we knew about the history of the cosmos. To understand what SPHEREx is truly set to accomplish, we need to break down how it actually works. SPHEREx is a small spacecraft, roughly the size of a refrigerator. But what it lacks in size, it makes up for in capability. Unlike traditional telescopes that focus on narrow fields of view or specific objects, SPHEREx is built for scale. It will perform all-sky surveys in infrared light, not once, but repeatedly every 6 months for at least 2 years. It's equipped with modest 20cm telescope, but the key lies in advanced spectrophotometers. These instruments allow it to split infrared light into dozens of narrow bands. This is where SPHEREx becomes powerful. Each point in the sky will be observed in 96 spectral bands, giving scientists a rich dataset of how light is absorbed and emitted across a vast range of wavelengths. Why is this important? Because different wavelengths of light can reveal different components of the universe. In visible light, we see stars and galaxies, but in infrared, we see what's hidden, called dust, molecular clouds, and the redshifted light of the earliest galaxies. SPHEREx will observe wavelengths between 0.75 and 5 microns, the sweet spot for detecting ancient light that has stretched across the cosmos for billions of years. This spectral information allows SPHEREx to do something no mission has done before: map the distribution of galaxies over cosmic time. It will measure the redshifts of over 450 million galaxies, creating a massive 3D map of the universe's large-scale structure. And that's where the mission intersects with the biggest question in cosmology. One of SPHEREx's goals is to test theories about cosmic inflation, the violent expansion of the universe that occurred just a fraction of a second after the Big Bang. Different inflationary models predict different patterns in how galaxies are clustered across vast distances. By analyzing these patterns on a scale never before achieved, SPHEREx may help rule out certain inflation models and narrow down what really happened at the dawn of time. This kind of data isn't just useful, it's foundational. SPHEREx will give us a clearer picture of the geometry, scale, and fate of the universe. And because it's scanning the entire sky, not just a selected portion, it will provide a cosmic baseline for generations of missions to come. If you're enjoying diving into the unknown with me today, don't forget to hit that subscribe button. It helps the channel grow and tells the algorithm you like the content that actually makes you think. Smash that like button if you learned something new, and share this video with a fellow space nerd or conspiracy theorist, and let's get the conversation going. And if you want to go even deeper, join our growing community on Reddit and Discord. Links are waiting for you down in the description. Now, back to the video. Beyond mapping the large-scale structure of the universe, SPHEREx has a second mission, one that brings the focus much closer to home, our own galaxy. and even the ingredients of life itself. While SPHEREx scans the sky in search of distant past, it will also be analyzing the interstellar medium of the Milky Way. That means it's not just looking for galaxies billions of light years away, it's also measuring the distribution of ices and organic molecules within our galactic neighborhood. This includes water ice, carbon dioxide, methane, and other compounds critical for formation of planets and potentially life. Most of these molecules form and reside in cold, dense regions of space, often in dusty disks that orbit around newborn stars. These protoplanetary disks are birthplaces of planetary systems, and until now they've been notoriously difficult to study in detail. They are dark, cold, and buried under clouds of gas and dust that visible light can't penetrate. But SPHEREx can see through that dust. Its infrared capabilities allow it to detect and analyze the spectral signatures of these ices, mapping them across the entire sky, including thousands of individual stars and planetary systems information. This will help scientists understand how often water and organic molecules are present during planet formation and whether our own solar system is typical or a rare exception. It's a chemical census of the galaxy, and the scale is unprecedented. SPHEREx will observe hundreds of millions of stars along with thousands of known exoplanet systems. It won't just tell us where organic compounds are found, it will help determine how they are distributed and how they evolve over time. This is where SPHEREx becomes more than a cosmology mission. It becomes a search for habitability. Because if water and complex organics are common in the early stages of planet formation, that changes how we think about life in the universe. It suggests that the building blocks of biology might be widespread and not rare at all, and that the conditions necessary for life could emerge in more places than we ever imagined. By combining deep cosmology with detailed chemistry, SPHEREx bridges two of humanity's biggest questions. Where did we come from? And are we alone in it? And the answers to both may begin with invisible light. So how exactly does SPHEREx fit into the broader picture of NASA's mission portfolio? The answer lies in its role as a pathfinder, a kind of a cosmic scout laying the groundwork for even more ambitious missions to come. SPHEREx is not a flagship mission, not like JWST for example. It's a small explorer mission, with a smaller budget and much faster development cycle. But that's precisely what makes it so valuable. Its job isn't to capture breathtaking images, it's to collect massive amounts of data. And that data is going to be indispensable for nearly every major space observatory coming online in the next decade. For example, the Nancy Grace Roman Space Telescope, scheduled to launch later this decade, will rely on SPHEREx's data to refine its targets. Roman is designed to study dark energy and exoplanets with incredible precision. But its field of view is narrow compared to SPHEREx's full sky survey. SPHEREx can help identify the most promising regions of the sky, helping Roman work smarter, not harder. Same goes for JWST. While Webb peers deep into the universe with astonishing clarity, it can't observe massive areas of sky. SPHEREx can act like a cosmic treasure map, highlighting where the most interesting and potentially groundbreaking targets might be hiding. But the ripple effects go even further. SPHEREx's all-sky infrared dataset will serve as a baseline for future missions we haven't even launched yet. Whether it's studying dark matter, looking for the first galaxies, or mapping exoplanet systems, nearly every future project will benefit from SPHEREx's foundational survey of the sky. And for astronomers on Earth, this means access to an unprecedented treasure trove of data. The entire SPHEREx catalog, covering hundreds of millions of galaxies and stars, will be made publicly available. That means researchers all over the world, from seasoned professionals to students just starting out, will be able to tap into a new layer of the universe. That's part of the mission's brilliance. It's not just designed to answer questions, it's designed to help others ask better ones. In a way, SPHEREx is like turning on lights in a room that's been dimly lit for decades. It won't show us everything, but it will reveal shapes and outlines of universe's deepest mysteries and point the way forward. In the grand narrative of space exploration, missions like SPHEREx don't always make the front page. They don't carry astronauts, they don't land on alien worlds, and they won't beam back dazzling photos of nebulae that go viral on social media. But don't let the quietness fool you. SPHEREx is doing something profound. It's lifting the veil on the invisible universe and giving us a glimpse into questions that have haunted humanity for centuries. Where did the cosmos begin? How did the first galaxies form? What are the odds that life could emerge elsewhere? And what hidden structures lie between galaxies beyond the reach of even our most powerful telescopes? These are not small questions, and SPHEREx isn't looking to answer them all at once. Instead, it's doing what science does best, collecting the clues. By surveying the entire sky in infrared light, SPHEREx is creating a cosmic blueprint. It's identifying the fingerprints of the earliest galaxies, tracing the ripples of inflation, and measuring the background light from billions of years of star formation. That's the fossil record of the universe, not in rocks, but in photons. But it's also deeply personal, because in the same data that tells us about galaxy clusters and dark energy, we also find evidence of water ice, carbon chains, and the raw chemistry of life. This mission isn't just looking out into the universe, it's looking back and, in a way, looking within. SPHEREx stands at a unique crossroads, between the birth of everything and the potential for life everywhere. It's a mission that bridges cosmology and astrobiology, theoretical physics, and planetary science, and its impact will extend far beyond its relatively short operational time. SPHEREx will scan the entire sky every 6 months for about 2 years, building a legacy dataset that researchers will mine for decades to come. This is what makes SPHEREx remarkable. It's not just a telescope. It's a storyteller, and the story it's telling is one of origins, of evolution, and of the universal patterns that connect us all. We may never find all the answers, but with missions like SPHEREx, we are at least learning how to ask the right questions, and to search for them in the light we can't even see. So the next time you look towards the night sky, remember, what you see is only a sliver of the truth. Beyond the stars your eyes can trace, there is an ocean of invisible light, an ancient echo of creation. The whispers of newborn galaxies, the glow of forming stars, and the spectral traces of life's chemical beginnings. And right now, orbiting above us in silence, a small but powerful spacecraft is listening. SPHEREx isn't here to dazzle us with spectacle. It's here to reveal the subtle, to chart the entire sky in wavelengths we can't see, but which hold the answers to our biggest questions. It's a reminder that the universe still has secrets, and we are getting better at uncovering them. And that's why missions like this matter, not because they instantly rewrite our textbooks, but because they quietly, methodically expand the edge of the known world, pixel by pixel, light by light. So, will SPHEREx find proof of alien life? Will it explain dark energy? Will it rewrite our origin story? Maybe not in one stroke, but it's a start. And sometimes the biggest revolutions in science begin with the smallest shifts in perspective. If this kind of mission fascinates you, if you are into the quiet explorers that shape our cosmic understanding, then stick around, because this is what we do here. Make sure to subscribe, drop a comment if you've heard of SPHEREx before today, and share this video with someone who thinks all the great space missions already happened. SPHEREx may not be flashy, but in the world of space science, sometimes the quietest missions echo the loudest across time. Thanks for watching, keep looking up.